and stoppage time.
Hello and welcome to another episode of Mechanics in Sport. Today we look at projectiles in football.
Raise the roof here with a goal. I don't believe it. David Beckham scores the goal to take England all the way to the World Cup finals.
To start off, we look at the football as a particle and we look at the forces acting upon it. We have a downward force that is a combination of the mass of the ball and the gravity coefficient. We write this as Gm. And then we have a upward force as the velocity at which the ball is kicked. This can be resolved, however, into two forces, one vertically and one horizontally to the path of the ball. We can then write this as a right angled triangle and use basic trigonometry to calculate these upwards, the vertical and horizontal force. Now we should look at an exam style question. A football is placed on a horizontal surface. It is then kicked so that it has an initial velocity of 12 meters per second at an angle of 40 degrees above the horizontal. A. Find the time it takes for the ball to reach its maximum height, and B. Hence show that the maximum height of the ball is 3.04 meters, correct to three significant figures. So to answer part A of this question, we'll start off by drawing a graph. This will help us visualise the path of the football. It makes it easier when you clearly label on your graph the angle at which the ball is kicked and also the velocity at which it is kicked. This curve just gives us a sort of idea of where the ball will end up, and that little marker tells us the maximum height of the ball. We'll use the Suvat equation V equals U plus AT to work out this first part. And we must make sure that we call every positive force acting in the upwards direction. Our U is 12 sine of 40 due to the trigonometry that we looked at in the earlier part of the video. And our acceleration is minus 9.8 because that is the coefficient of gravity and it is in the negative direction. At the maximum height, the velocity of the ball will be 0, thus at this point V equals 0. We then put all this into our equation and we can rearrange to find T. Therefore we have T as 0.787 seconds to three significant figures. And finally, for part B of the question, we're going to use a different type of Suvat equation, S equals UT plus a half AT squared. We again look at every force acting in the vertical upwards direction as being positive. We know that our U is 12 sine of 40. Our acceleration is still minus 9.8. And our T from part A is 0.787 seconds. Putting all of this into the Suvat equation gives us that S equals 12 sine of 40 T minus 4.9 0.787 squared. Using a calculator, we can show that this is equal to 3.0355, which is 3.04 to three significant figures. Thanks for watching.